Alright everybody, so today we are going to do investigation 2.4, how do parts of the solar system interact? And so what we're going to do is that we're going to be talking about a few different things today. Our first thing, pardon me, need my pens. Our first thing is the word solar. Now solar refers to the word sol, which is the same as sun. A system, as we know, is a series or set of objects. Let's see if I can minutes. There we go. Series of objects working together. Can any of you name a type of system? Think about it for a second, alright? It's a series or set of objects working together. Alright, so we are going to be figuring out really how does our solar system work together. And what we're going to do is everybody's going, well, I have a set of cards. And they have different planets on them. They have the sun. They also have different moons. Alright, and what we're going to do is we're going to put them into groups of similar characteristics. First, what we're going to do is we can look at the back of it. And you can see that it says, so like the sun says sun, type is a star, diameter, average temperature, and composition. So what do you think one way is that we could put them together? How could we group things? I can't spell today. How could we group things together? All right, good, you're right. We could group it by type. So, example, star. Star, planet. Let's see, this one that I've just picked up, Phobos is a satellite. Alright, we'll get into that. Next, we could do it by composition. And by composition, I mean what is it made out of? So composition, example, gas. Venus is, let's see if we go down here, composition is rock. Earth, rock and water. Moon, rock. Let's see, rock and ice. So ice is another one. Does anybody have any other different ideas? All right, well, let's put them together. And then I will tell you guys a few more. All right, so we have Pluto, dwarf planet, distance from the sun, orbit period. Now the thing about a bunch of these is that they're going to give you an orbit period, and that tells you how long it takes for it to rotate, revolve around the sun. I meant to say revolve. All right. Also tells you on these that Pluto has 5 moons and that there are no rings on it. Triton is a satellite. I was thinking I was going to put planets together, satellites together, and then we'll go through them. All right, Ida, however, is an asteroid, so that's a different one. Okay, so what we have here is we have a group of planets, our group of satellites, We have a star, we have an asteroid, and then Halley's Comet is a comet. All right, different ways we could put it together. I mean, we could do it together by, we could do temperature. We could do it by diameter. Which ones are similar in size? Let's see, distance from sun. And orbit period. The thing is, not all of these are going to tell us the orbit period, but we could try that. Let's try the orbit period. All right, Halley's Comet orbit period is 76 years. Now the sun does not orbit, so that's going to just be in its own group. Ida is an asteroid. Its orbit period is only 4.8 years. And what they do in the back of these cards is that they list them by Earth years rather than anything else. It's simpler. All right, Venus, 225 days. So I suppose we could put the ones that are days rather than years. So Ida and Halley's Comet could go together because they're years. Earth, 365 days. Mars, 1.9 years. Mercury, 88 days. Jupiter, 11.9 years. Saturn, 29.5 years. Uranus, 84 years. Neptune, 165 years. And Pluto, 248 years. All right, the moon, 27.3 days. Okay, Phoebus is a little satellite. All right, everybody see the Phoebus, the satellite? Now, Phoebus has something unique. Phoebus's orbit period is 7.7 hours. Io is another satellite. All right, her orbit period is only 42.5 Earth hours. Tethys, 1.9 years. All right, this one's a satellite, but it takes years for it to orbit. Miranda, 1.4 days. And Triton is another satellite, 5.9 years. All right, so we've grouped them a second way. First, we grouped them by type. Then we grouped them by orbit period. We could, if we wanted to, do it by composition. So the sun is made out of gas. Io is rock. And I'll just, so we've got gas, rock, and I'm sure we'll come across something else. Next one is Phoebus, rock. Miranda, rock and ice. I think, do we want to put this with rock, or do we want to put it with ice, or does it get its own? Or should we just say multiple compositions? All right, we can do multiple compositions. So Miranda's going to go there. The moon is made out of rock. Mercury, rock. Earth, rock and water, so multiple compositions. Venus is rock. Triton, rock and ice. Tethys, rock and ice. Pluto, rock and ice. Neptune, gas and ice. Uranus, gas. Saturn is a gas planet. Jupiter is also gas. Mars is a rock planet. Ida is a rock asteroid. And then Halley's Comet is made up of several things. Ice, carbon monoxide, carbon dioxide, ammonia, methane, rock, and dust. And a fun fact about Halley's Comet, it has not been seen since 1986. And remember, it does take 76 years. So, if theoretically Halley's Comet was going to turn up again, all right, 1986, and we know that it orbits every 76 years, we could do this quickly, figure out approximately when Halley's Comet would come back. So that's 16. Let's see. All right, so Halley's Comet In the year 2062, so in about 40 years, 42 years, Halley's Comet should be back in orbit, and we should see her. I think it's a very pretty comet. All right, and do you guys remember what I mean by orbit? I keep saying it a lot, and I'm not sure. I just want to make sure that you guys are understanding exactly where I'm coming from. Orbit means to revolve or move in a path around another object. All right, so here's our sun. And here's our little planet. It's badly drawn. All right, the Earth is revolving around the sun, or it's orbiting. All right, so what we're going to do, 1 minute. Is that we are going to put, 1 second, I just want to make sure that I'm doing this right. Yes, I am. Okay, I just got a little bit ahead of myself in the beginning, but that's fine. It'll still work. So what we're going to do is we're going to put them in order of really where they fall from the sun all the way out. So we've got all of our different ones. Let's see if I can make this smaller. There we go. All right, okay, this is what Pluto looks like. And I'm probably going to have to flip these over at some point so that you guys can all see them. All right, so here's the sun, and the sun is our starting point. So after the sun, which is the closest thing to it? All right, so the closest planet to the sun is Mercury. So we just have to find Mercury, and I should have not flipped these over. Here's Mercury. So Mercury. So Sun, Mercury. Next comes Venus. After Venus comes Earth. All right, and then we're going to go on to, what's the next planet after Earth? Does anybody remember? I'll give you a hint. It's named after the god of war in Roman. All right, we talked about Rome a little bit. All right, good. Next one is Mars. So there is Mars. After Mars comes the asteroid belt. So let's find the asteroids. Here's Ida, the asteroid belt. Next is Jupiter. That's not that one's Jupiter. There's Jupiter. And then after Jupiter comes Saturn. And we're going to use all these different satellites and stuff because they orbit different planets. So after Saturn comes Uranus. Then comes Neptune, the blue planet. After this is not a planet. After this comes Halley's Comet. Then comes our friend Pluto. Now we have several ones left. We have Triton, Miranda, Io, Phoebus, the Moon, and Thesis. Now they all orbit something else. And if we read on it, so the Moon, distance from Earth. All right, we know that the Moon goes with Earth. The rest of them, such as like Miranda, says distance from Uranus. And so we'll put we'll put Miranda with Uranus. Triton goes with Neptune. Next comes Thesis with Saturn. Then comes Io from Jupiter. And then Phoebus goes with Mars. All right, so we've got all of our different planets and their different satellites laid out so that we can see where they go. So what we're going to do now is we're going to fill out our worksheet. So I want everybody to get out number 9, which says Solar System Data. And the first one is record the planets and other solar system objects in order, starting with the Sun. Use the table on the left side of this sheet. If the planet has a moon, write its name in the space below the planet. All right, I think we can do this. And so we can see it starts with, I'll get used to this thing eventually. There we go, Sun. Here's the Sun. Next comes Mercury. Then comes Venus, Earth, Mars, asteroids, Jupiter, Saturn, Uranus, Neptune, Halley's Comet, which I'm just going to abbreviate to H, Comet, and then Pluto. And then underneath, so under Earth, we'll write Moon. Under Mars, we'll write Phoebus. Under Jupiter, we'll write Io. Thesis goes under Saturn. Uranus has Miranda. And Neptune has Triton. All right, so now what we're going to do is we're going to lightly shade in. Well, I think you guys can manage this part. All right, whichever planet is made out of gas, I'm just going to have you guys circle, or you can shade in. So let's go through our planets. Pluto is made of rock, so not Pluto. Neptune is a gas, so we're going to circle Neptune. Uranus is made out of gas, so we're going to circle. Saturn is a gas planet. Jupiter is a gas planet. Let's see, and I believe there shouldn't be any more rock planets. And then, of course, the Sun. We're going to circle because it's made out of gas as well. Now what we're going to do, how big are the planets? Write the names of the planets in order from the largest diameter to the smallest. All right? So, which one's the largest? Which one's the smallest? I'm going to get rid of the extra cards because they're a little bit in my way at the moment. And this is a bit of a tiny sheet, so I'm going to write it out on my bigger one. All right, so we're just gonna, I'm gonna list out the names, and we're gonna write the diameter, and then we'll order them. So Venus is 12,104 kilometers. Mercury is 4,879 kilometers. And remember, largest to smallest. So don't worry that they're not in order at the moment. We'll order them. Earth is 12,742 kilometers. Saturn is 120,536 kilometers. All right, Saturn's currently winning. Jupiter is 139,822 kilometers. All right, Jupiter's doing better. Mars is 6,779 kilometers. And I've got 3 under here still. All right, Pluto is 2,302 kilometers. Uranus is 51,118 kilometers. And our last planet is Neptune, which is 49,244 kilometers. All right, so let's look at these. Which one's obviously the biggest? All right, well, I'm thinking Jupiter at 139,822 kilometers. So we're going to put a little 1. Next is, I'd say Saturn at 120,536 kilometers. So now, who's next? All right, we have 12,000, 49. Okay, Uranus is next at 51,000 and some odd kilometers. Right under that is going to be Neptune. All right, so from 49, it suddenly goes all the way down to 12. So Venus is 12,104 kilometers. Earth is 12,742 kilometers. We're just a little bit bigger than Venus. So Earth is 5, Venus is 6. Next comes Mars at 6,779. After that comes Mercury at 4,879. And then Pluto is number 9 at 2,302 kilometers. All right. Okay, and we've done pretty much the rest of the worksheet kind of together when we were grouping things. All right, so such as how long does it take for a planet to orbit the sun? All right, we can run through them. So here's orbit. And fastest to shortest. I meant longest. So Mercury, and I'm just going to put ME. Mercury, 88 days. Venus, 225 days. Neptune, 165 years. Uranus, 84 years. Pluto, 248 years. Mars is 1.9 years. Jupiter is 119 years. Saturn is 29.5 years. And Earth is 365 days. Now, I'm going to give you guys a hint right here. The farther the planet is away from the sun, the longer it's going to take. So, if we look at the data, Pluto is going to take the longest to orbit the sun. After Pluto, let's see, okay, we have 119 years, 160, so Neptune would be next at 165 years. After that would come Jupiter at 119 years. Let's see, what do we have left for years? We have 84 years, 1.9 years, and 29. So Uranus is next at 84 years. Saturn at 29.5 years. And then Mars at 1.9 years. And then we go into the days. So we have 365 days. Is us. Number 8 would be Venus at 225 days, and then Mercury at 88 days. All right, so we've got a couple new terms for us to learn today. We have terrestrial. These are the 4 rocky planets. Terrestrial means land. All right, the next 4 planets beyond the asteroids are called the gas giant planets. All right, and the reason they're called this is because they're made out of gas. And then we've got a few other weird ones. So we've got Pluto. Pluto is a dwarf planet. And it's in part of the solar system that's filled with chunks of debris that is a lot like, okay, have you ever seen after an ice storm, all right, you know how there's all kinds of clear ice? Well, then after, like, the road company comes through and they clean it all off, and you know how it gets really dirty? Think of the whole space area outside next to Pluto covered in stuff like that, all right? It's a dirty ice. There are frozen dust and water and gas, and this region is known as the Kuiper Belt. I don't think I'm saying that right. And some of these chunks are going to be planet-sized, and so Pluto is referred to as a rock and ice dwarf planet or as an object from this belt. And even farther out is another dwarf planet. So there's another dwarf planet past Pluto named Eris. And then there's going to be comets, such as Halley's Comet, that travel throughout the solar system, orbiting the sun in an oval pattern. All right, and so this is the perfect time for you guys, if you haven't already done so, read the pages about exploring the solar system, and this will talk about all the different planets. Let me flip to it so I can show you guys. It'll talk about all the different planets that are in the solar system in a little bit more detail, such as, so like here, you can read about the sun. All right, it'll go over those key terms that we just talked about, and then it breaks it up. So we've got our terrestrial planets, such as Mercury, Venus, Earth, and Mars. All right, it talks about each of them, and you guys can use this chapter when you do your planet research. And then there's the asteroid, a little bit about the asteroid belt. And the asteroid belt, all right, remember we talked just a little bit about Ida, the asteroid? All right, Ida has her own moon called Dactyl. All right, she's big enough that she has a moon that orbits her. And then there's going to be 4 different, there's going to be 4 gas planets: Jupiter, Saturn, Neptune, and Uranus. All right, and Jupiter has quite a lot of moons. All right, lots of these planets are going to have their own moon, but we just kind of picked one. All right, there are 4 main large ones. All right, Jupiter has Ganymede, Callisto, Io, and Europa. Then talks about Saturn, talks about Uranus and Neptune, and then the Kuiper Belt. So a little bit about Pluto, and then about Eris, and then a little bit more about the comets. All right, and then I want you guys to answer questions 1 through 6. All right, this page, the planets of the solar system, shows you in the order, the relative size of the planets. All right, this map does not show you Eris because she's technically not classified as a planet. Just as you remember how Pluto, there's a whole thing about if Pluto's a planet or not. And since Pluto's technically a dwarf planet, they don't consider it as such. But for this time and purpose, we're going to use it. And then there's a third reading that goes along with this lesson. Why doesn't Earth fly off into space? And there are 3 questions that I would like you guys to answer about those. All right? I believe, let's see, is this the one with, yes. After you guys have done those readings, there's also a video that I wanted you guys to watch. So if you go onto FastWeb and you go to streaming videos, you can find the one called The Planets and the Solar System, and this takes you about 24 minutes to do. And I want you guys to just read those, and it'll go over the different planets a little bit more, and you'll see some more pictures of it. All right, and I will see you guys later. Have a good week.